Hello, I'm here at Embedded World 2024 on the DigiKey stand, and I'm pleased to be joined by Anders Frederiksen, the Strategic Marketing Manager for Robotics and Emerging Technologies at Analog Devices. So thank you very much for joining us. It's a pleasure to have you. So today we're going to be talking about robotics and intelligent machines and how sensor fusion can enhance their capabilities.
Correct.
But before we get into that, can you just give us a brief introduction of yourself and your background?
I can. I've multiple hats on during my career expansion in ADI. I've been there almost 25 years. So I've been a lot of years with a lot of different technology areas in analog devices, from motion control, component designs, into kind of more system-oriented capabilities and what we're selling. And right now I'm in robotics, kind of facilitating and leading our efforts around how do ADI deploy the best solution in robotics.
Yeah.
So it's an interesting area because it's so diversified in regards to which technologies are being used and can be used in robotics. And that's what I do right now.
Yeah, fantastic. Well, kick us off then. Why don't you start by explaining the fundamental principles behind sensor fusion, especially in regards to robotics and intelligent machines?
So what is interesting there is that we've been over the last years looked upon how do you take data from sensors, because what we do in analog devices is we bridges the physical domain, which is how you engage from sensor, through the acquisition of data, the actuation, and basically digitizing the entire data stream in an environment that allow you to either fuse or do kind of changes of the data so that you can operate a robot or a machine on that.
Okay.
And the sensor fusion piece is suddenly coming together because the digital piece, the controller, is now so powerful that we can take multiple stream of sensor input from cameras or radars or lidars into a sensor processor platform and fuse that together. The interesting piece here is that a few years ago, you couldn't do that at real time. And in robotics, what is really, really key is that you can detect and articulate data because you need to act upon that data in real time.
Yeah.
Because otherwise you have moves and you might bump into something, you might kind of not avoid an obstacle, and this is where it's critical. So we're bridging kind of the physical domain to the digital domain. And that's where the fusion piece becomes interesting because it's all about how do I get data from the sensors to my compute unit as fast as possible.
Yeah.
Lowest latency possible.
Okay. And what are some of the main challenges then that people are facing with regards to sensor fusion for robotics?
It's kind of been an evolution because in the beginning people were saying, well, we can operate our systems fine, but once you now imagine having a robotic system here in this event, it needs to act fast.
Yes.
And some of the problems that we are overcoming and trying to overcome better and better are the latency aspect, because you want to have as much data as possible through your pipeline, through your medium. And that medium is critical. I'm going to come back to that.
Yep.
That medium needs to deliver lowest latency. And once you get that data, you need to be able to kind of correlate that data in a form that now bring you this, we call it real-time awareness.
Yeah.
That's really the problem our customers are trying to solve. And we're enabling them through a multiple set of technologies now that enable that functionality.
Yeah, fantastic. And with a variety of sensors available, we've got LiDAR, radar, cameras, IMUs. How does sensor fusion integrate data from these diverse sources to create sort of a coherent understanding of its environment?
So all sensors are different, and that's the luxury of those. And what we've learned is that one of the technology areas that were developed actually by Maxim, which Analog Devices acquired, is GMSL.
Okay.
And GMSL, Gigabit Media Layer Serial Link, is actually delivering almost latency-free data over a SerDes pair that allow you to get real-time and diagnosed data from sensor to your control unit I'd say at real time, because I've used that phrase many times, but I think the criticality is that if it's a LiDAR, or if it's a radar, or if it's a camera, if it's a time-of-flight unit, it doesn't really matter as long as the output medium is the same.
Okay.
And we can treat that data now synchronized with unique timing, unique sensing functionality for their, let's say, even keeping it at the edge, because we can control it at the edge as a unit that deliver sensor fusion value.
Yeah, okay. Are there differences in sensor fusion techniques or challenges when applied to indoor robots compared to sort of your outdoor autonomous vehicles? And, how does the environmental factor influence that?
So there definitely is.
Yeah.
If you look at a high level, sensor fusion is basically just taking normal set of sensors, collating the data you want to correlate, and then use that data output, which is the one you selected, for your given premises.
Yeah.
And for sure, outdoor, we have different lumen, different light. We have different there could be haze, there could be rain, there could be other elements. So that's where the sensors need to be kind of agnostic to the given elements. So I would say from an overall architecture point of view, sensor fusion is just a method of taking data, fuse it, and pick out the right set of values which you want to use.
Yeah.
So there isn't at a high level differences, but the minute you dive into the different sensors, the different outcome of those sensors, there's a huge spread of functionality which we want to enable and allow customers to use. And that's why we're actually looking at how can we get raw data through these pipes, because once we deliver raw data, it's kind of free to use whatever is important for that given environment. However, there's a problem with raw data, and that's raw data is a massive amount of load on the pipeline, on the data path, and GMSL is unique for that.
Yeah. Okay, so following on from that then, how is ADI enabling world-class fusion with the GMSL technology?
So we are enabling that with things like, we call it moving into subsystem solutions, moving into solutions that deliver first of all, the capability showcase of how can ADI enable sensor fusion.
Yeah.
So we decided to do a 8-channel, what is called GMSL to Ethernet unit that has the capability of streaming and getting raw data from cameras, LiDAR, radar, or whatever, at real time, timestamped into a compute unit.
Yeah.
The uniqueness of that is that you can synchronize up to 8 sensors. You can timestamp them independently, which makes the fusion piece easier for the user, the guys to deploy the software. And now you have that link to your 10 gigabit bridge to the PC or whatever you do from an application layer and application support front end.
Yeah, fantastic. And how does this technology, particularly the GMSL 2 gigabyte Ethernet converter, address the challenges that we've spoken about so far?
So there's a lot of way that our customers have taken existing off-the-shelf solutions. They've taken compute boxes, they've taken sensor units, they've taken multiple of these because the compute functionality is critical, the performance of the throughput is critical. So what we've done, we've taken the same approach. However, we've scaled it down to a level that is almost, as I said, at the edge, that solves a lot of the hardcore data function. And what we're enabling for our customers is with this unit connected with real cameras, real sensors, we are taking time off the development.
Yeah.
Because they can take this unit, which is, of course, scalable. It has software framework. It's running on ROS. So you can actually take your independent sensors, use this development platform as a module in your full-blown design.
Yeah.
And this is quite unique for analog devices because normally we sell standard components.
Of course, yeah. Tell us more about how you're partnering with sort of Tier 4 and the inclusion of edge auto software in the ecosystem.
Yeah, so the funny way around this was that we were looking for, so we are expanding heavily in the robotics domain. Nobody can survive without the ecosystem. And we're actually developing quite a broadness and a broad scene around how do we enable different partners and our different solutions in robotics. And one piece was this: how do we get up to 8 cameras synchronized in a real fashion? So we met up with a company called Tier 4 out of Japan, and they had the same kind of challenge. They had the problem that they needed multiple set of hardware to do one function, and we agreed to do a development with them. And this is this GMSL to 10 gigabit Ethernet converter box. The lucky thing is they have worked in autonomy for the last decade.
Yeah.
And the autonomy is that they have expertise on how to do sensor fusion, but not just sensor fusion, also the navigation, the obstacle avoidance, the avoidance of human identification. So the whole software application is where Tier 4 has a lot of value beyond what analog devices normally do.
Yeah.
So for us, it was very good to see that the ecosystem expansion allowed us to take our hardware and hardcore capability, bridge that into a real application, which could be an autonomous tractor, it could be an autonomous taxi, or it could be a real hardcore robotic machine.
Yeah.
But Tier 4 is enabling us with their autonomous software to actually allow us to suddenly solve another problem in the kind of the value chain for our customer, because we can point them to Tier 4 as a main player in how we solve sensor fusion.
Fantastic. And tell us more about something I love the name of, which is Adam, Analog Devices Autonomous Mobile.
Correct.
So what are you aiming to showcase here with Adam?
And it's funny because we've been going down the path of this: how do we enable the market quicker with our capability, not just components, but capabilities and solutions? And how do we let our customer, we guide them on a path which is simpler for them to focus on their IP?
Yeah.
So we developed Adam, a mobile robot platform that are using our core modules. So Analog Devices have, as I said, bridging the physics to the digital domain, so we have everything in kind of component related. So what we're doing is, with Adam, we build modules that basically can plug in a ROS environment to control motors, to take sensor fusion, to take different sensors. So it could be time of flight, it could be standard RGB, it could be IMU, it could even be controlling the power of the batteries. So we build all the different modules on our technologies.
Yeah.
And that allows suddenly our discussion with customers, it moves up a level to embrace the core functionality of the end equipment, not the component functionality.
Yeah.
So Adam is a great vehicle for Analog Devices to suddenly, let's call it, stimulate new discussions around future requirements, next steps, and so forth.
Yeah.
But also showcase, this is a real example of how you drive 2 wheels or 4 wheels in a robot platform.
Yeah. The most important question is who came up with the name Adam?
That's actually a good. So we were talking about Adam, and we're developing a couple of others. So there might be an Eve at some point. But I think Adam was one of our design directors, so he came up with that. It's a great name.
It's fantastic. I love it. Brilliant. Well, thank you very much for your insights. But before we wrap up, is there anything else you wanted to share with the community?
So I think it's an opportunity here, at least for this week. We're in Embedded World. It's a great event. There's a massive amount of people here already now. It's early first day.
Yeah.
Come and visit Analog Devices. We are at ADI at Embedded World. We're in a booth where we have 12 different demos, or more actually, but we're showcasing, again, how do we bridge the physical domain into what are we doing in the edge, on the digital side, and how do we leverage that with our components, with our subsystem, and even down to a product level system. And this is an evolution which is really nice to see. So come and visit us at Embedded World.
Yeah, brilliant. Well, thank you very much, Anders. It's been a pleasure having you.
Likewise.
Thank you.
Thank you so much.
You're welcome.
Thank you.